All right, so let's draw it. You have, I saw everybody's paper look good with this kind of thing going on from 1 to 1, right? So you have your representative dx in there like that, and you're coming around and you stop halfway with your cross section, and you're ignoring that fact that it's going to have a slant on that. That's because you know that it's going to go to 0, right? So you say, okay, wow, that's still a cylinder. Now the radius, I know my thickness is still dx, my height, and my radius is what? From my axis of rotation. What's my radius? Is it always 1?
No.
What is it? The function. It varies. The radius is the functional value, right? The radius varies with the function. As x moves along, as you are at different x's, you have a different radius, depending on what the function is, right? So the radius will vary with the function. So how do we do that? How do we find the volume of one of these then? Which is what? Volume of one cylinder. Volume of one of these. Ernie?
Pi times negative x plus 1 squared.
Function negative x plus 1 squared.
Times dx.
Dx is the height, right? And if we want the volume of the whole cone, what should we do?
Integrate from 0 to 1.
Integrate now from 0 to 1. Pi is a constant. A negative x plus 1 quantity squared dx. Does that look like something we could integrate? It does. You could. What's the easiest way to integrate this?
You sub.
Maybe you, I don't know, maybe not use sub. I might just FOIL it out. X squared, I think it's minus 2x plus 1. Integrate term by term. Integrate up here, term by term. 1/3 x to the third minus 2x squared over 2 plus x, evaluated from 0 to 1. 1/3 minus 1 plus 1, and then everything has a 0 in it for the other side, right? So we end up with 1/3 times pi, which is pi over 3. Does that look familiar? Where did you get that pi over 3 value from before? Volume of a cone. Volume of a cone is what?
1/3 pi r squared times 7.
And our height was 1, and our radius was 1 in our cone, right? So we got pi over 3 for this problem anyway, didn't we? What would you rather use to get the volume? Be honest. The formula, right? Absolutely you'd rather use the formula. Anytime you're in calculus and you run across a shape that you know, use the formula. Don't do the calculus if you don't have to. What's going to happen, do you think? What do you think is going to happen with our problems? We're going to need to use integration, right? Where it's not going to be a shape that you can name. That's where we're going to find the volume of these, all kinds of things in our world that we use are rotations. Okay, let me show you this equation. Let's change this real quick. This will be negative x plus 1. I'll reset that. I'll change my... All right, so that's what you have now, right?
Yes.
So if we rotate one of these, it's still a cylinder, right? Still a cylinder. And if we see all of them, you can see that they change their height of each one, or in other words, because it's on the side, what's changing as it goes down the line? The radius, that's right.